Okay, so today we're gonna start our lessons over Unit 2, which is equations and inequalities. So the very first thing is I would like for you just to get a piece of paper. It can be notebook paper, it can be any type of paper. I just have some blue computer paper so you can kind of see it. And what we're gonna do is we're gonna fold it in half. You'll just fold with me as we go. So I'm gonna fold it in half, I'm gonna open it back up, and then I'm going to fold it kind of with, we call it make some doors, right? So you're gonna fold the sides into the middle. So it looks like doors, okay? And then the last fold I'm gonna make is I'm gonna fold them over onto each other. Doesn't have to be perfect. We're just trying to split it into 4 sections, okay? So when I open it back up, this is the front of my foldable. Okay, so the front of my foldable looks like this, and we're gonna get started from here. Okay, so we are going to review one-step equations today. So today we are just reviewing one-step equations. So one-step equations, there's 4 different types, okay? We've got addition, we've got subtraction, we've got multiplication, and we've got division. So you're gonna see 4 different types today. We're not gonna stay in one-step equations very long because we're gonna move tomorrow to the 7th grade skill, which is 2-step equations. But for today, we're gonna go ahead and review one-step equations. So let's talk through one of the most important things about equations in general, whether they're 1-step, 2-step, multi-step, is to always keep it balanced. Keep your equation balanced. Basically what that means, and I'm going to write it in a different color, is whatever you do to one side you do to the other. So we're gonna talk a lot about that, but for right now, we're just gonna start by writing that. So anytime we have a one-step equation that just is an addition problem, we're going to solve it in a certain way. So I'm gonna put to solve, we're gonna isolate the variable, and let's talk about that word isolate, right? Isolate means to get by itself. So we wanna get the variable by itself by adding the opposite. And I'm gonna put here in parentheses, and we're gonna use a mathematical term of the constant. So if you guys have your crossword puzzle, right? This is your Unit 2 crossword puzzle, and hopefully you got that on Friday or on really today. You might have finished that after your test. So constant, if we say 7 down, okay? Constant is a fixed value that does not appear with a variable. So we're gonna look at what that looks like here in just a minute, but that's what a constant is, okay? So that's gonna be some vocabulary that we're gonna use quite a bit. So I'm gonna underline that, it's super important. So we're gonna open up our foldable, and all of the addition problems that we're gonna do are gonna be in this little section right here, okay? So if you want to, you're welcome to draw the lines. Maybe it will help you to stay organized. And I'll tell you exactly where we're gonna write. So I'm gonna close this guy back up. That's just subtraction and division are gonna go over there. This bottom section is going to be for multiplication. So this part right here, we're gonna do some examples with one-step equations with addition. So I'm gonna give us 4 examples, and I'm gonna do each one kind of in a different color so that we can really see what's happening at this point, okay? So we'll start with our first one-step equation, and it's basically gonna say 35 plus x equals 98, okay? 35 plus x equals 98. I'm gonna draw my line because when it says keep it balanced, keep your equation balanced, whatever I do to this side of the equation, I have to do to this side. That's what keep it balanced means, okay? So let's talk through what it says. It says that a constant, right, our definition, I'm looking back at it, is a fixed value that does not appear with a variable. This is your constant. This is your variable. Notice there's an operation in between those, so those are separate things. So this is your constant, and I'm just gonna write con on top, okay? So that we know that's our constant. And what our steps say is to isolate the variable by adding the opposite of the constant. So if the constant is 35, think in your head, what's the opposite of 35? Hopefully you said negative 35. So I'm gonna add a negative 35 over here. Whatever I do to one side, I do to the other. And that's where keeping it balanced comes into play, right? 35 plus negative 35, those cancel. What's left over here, hopefully you realize, is x. And 98 and negative 35, they're not on the same team, right? One's a positive, one's a negative. So what I do is an itty bitty bit of subtraction. I subtract their absolute values to figure out how many 0 pairs have come out. 8 minus 5 is 3. 9 minus 3 is 6. So we get x equals 63, okay? Could I plug this back in? Absolutely. So if we want to look at proficient work and what proficient work looks like, which means perfect work, we would go back and we would plug our answer back into our equation. So does 35 plus 63 equal 98? Well, 35 plus 63 is 98, so our answer is correct. Okay? All right. So our next example, still under the whole addition section, our next example is going to be b plus negative 5 equals 17. b plus negative 5 equals 17. So let's go back to our steps. You're going to keep it balanced. You're going to get the variable by itself or isolate the variable by adding the opposite of the constant. Notice, this is your total. This is your variable. So this one is your constant. Remember, going back to that definition, constant is a fixed value that does not appear with the variable. Every time I've got my crossword over on the right side and I'm looking at that. So I'm gonna add the opposite of a negative 5. Well, hopefully you know the opposite of negative 5 is positive 5. Whatever I do to one side, I do to the other. Okay, let me cover this up so we don't get confused. 5 and negative 5, they cancel. So have we isolated our variable? Is it the only thing over here? Absolutely. And 17 plus 5 is 22. Okay, so we should be able to check our work. We're gonna plug our answer back in. So it should say 22 plus negative 5 equals 17. Well, 22 and negative 5 are on different teams, so they'd battle, and we would get 17, so our answer is correct. Okay? All right. Let's do one more in this section, and then we're gonna move on. So one more in this section, we're gonna say 15 equals y plus 2. 15 equals y plus 2. Okay, so I'm gonna draw my line. Again, whatever we do to one side, we do to the other. Okay, so back to our foldable. To solve, we're gonna isolate the variable by adding the opposite of the constant. So hopefully you've noticed this equation has the variable on the other side, which is totally fine, okay? So what I'm gonna do, I'm gonna give you about 45 seconds, maybe a minute, to try and work that one out, show the correct algebraic process. Okay, so hopefully what you've done is you have seen that 2 is your constant, right? And because 2 is your constant, we're gonna add the opposite of the constant. That's gonna be plus a negative 2, plus a negative 2. Make sure you're actually writing your operation signs, because if not, we get a little bit confused. 2 and negative 2, they cancel. And what we're left with, we've got y over here, 15 and negative 2. They're not on the same team, so they battle, okay? So we have 13 left over. Some of you guys might need to do that in the scratch work, but I think most of us know 15 minus 2 is 13, right? So now we plug it back in to have proficient work and to check it. So 15 equals, we're gonna plug in our y, 13 plus 2. Well, 13 plus 2 is 15, so we're good to go. Okay, we're going to leave this guy. We're not gonna do 4 examples on every single one. So let's go over to subtraction, and we're gonna do 2 subtraction examples. So that's 2 subtraction right here. But let's talk about subtraction. The very first thing that we have to remember when we have a one-step equation with subtraction, it's gonna be the exact same thing. Keep it balanced. This is gonna be for your entire algebraic career. You're always gonna keep things balanced. So whatever you do to one side, you do to the other. To solve, I wonder if anybody can think about what we do with a subtraction sign when we see one. So to solve these type of equations, what you're gonna do is to use something we used with integers last week. Some of you guys hopefully remember LCO, right? Anytime we see a subtraction sign in an equation, we're gonna use LCO. And once we do that, it just becomes an addition problem. So we're gonna use LCO, then we're gonna follow this exact same rule, okay? So let's do 2 examples. So let's say we have an equation that says r minus 15, okay? R minus 15 equals negative 75. And the reason I'm putting that negative 75 in parentheses is so that we can see that it actually is a negative, okay? So I'm gonna rewrite this so that we'll see the original problem. R minus 15 equals negative 75. I'm gonna draw my line. The very first thing that we're gonna do with this is to use LCO. So hopefully you've already seen, we're gonna leave the first term. Remember, it's not a number anymore, it's a term. Change subtraction to addition. I need the opposite of 15, which is negative 15. Now it literally becomes, because it's an addition problem, you do the exact same thing that you did before. So I'm gonna go back and use the same color because now we're getting rid of the constant with addition, right? So our constant, the number, the term that does not appear with the variable is negative 15 So to get rid of a negative 15, we're gonna add the opposite, which is a positive 15. Whatever I do to one side, I do to the other. 15 and negative 15, they cancel. So over here, we're left with R equals negative 75 and positive 15. They're not on the same team. So I'm gonna come over here and do some scratch work. Because they're not on the same team, they're gonna battle. So there's 60 left over after my 0 pairs. Then the team that had the largest absolute value was negative. So my answer is negative 60. This one we're gonna go ahead and check using our little proficiency scale. Basically, when we have R, right, we're plugging in negative 60 minus 15 equals negative 75. Some of you are questioning why we use LCO. Negative 60 minus 15. Some of us might say that that's negative 45. Okay, it's not. You have negative $60 and you're taking away another 15. So the reason that we use LCO is so that we can have less errors, leave, change, opposite. Well, negative 60 plus negative 15 is negative 75. So negative 75 equals negative 75, so we're good. So that means our answer is correct. Okay? All right, let's do another example, one more subtraction example, and then we'll go to multiplication and division. So 2 equals y minus negative 13. 2 equals y minus negative 13. I'm gonna leave the original problem. Y minus negative 13. I'm gonna draw my line, okay? To solve with subtraction, we use LCO first. So anytime I see a subtraction sign, now notice, I'm not gonna all of a sudden do LCO backwards. I'm not gonna leave change opposite. No, we always read left to right, so LCO happens left to right. So I'm gonna find my subtraction sign. The C always goes on top of the subtraction. So we're gonna leave the first term, change subtraction to addition, and do the opposite of 13, which is, of negative 13, which is positive 13. All I did was LCO. I haven't done anything else yet, but I did my LCO step, right? So now it says to isolate the variable by adding the opposite of the constant, okay? The opposite of positive 13, that means I'm gonna add a negative 13, and whatever I do to one side, I do to the other. Sorry, I couldn't see that. So I added a negative 13 on one side, and I added a negative 13 on the other. What happens to 13 and negative 13? Well, they cancel, which is what we want. So we're left with y on this side. Negative 13 and positive 12, positive 2, they battle because they're not on the same team. And we get 11, and which team won? It was the negative team, okay? Again, we could plug this one back in and show our proficient work here. 2 equals, where we see y, we're gonna plug in negative 11 minus negative 13. This gets really tricky if we don't use LCO, so that's one of the reasons we're really encouraging you. Leave the first term, change subtraction to addition. I need the opposite of negative 13, which is positive 13. So this is positive 13 plus negative 11. They battle, and we get 2, and our answer is correct, okay? All right, we're gonna do a few examples for multiplication and division, and really tomorrow what happens is this whole foldable becomes your 2-step equations for 7th grade, okay? I bet you can guess what the very first thing for both of these is gonna be. Keep it balanced. And still for division also is gonna be keep it balanced. Okay, so to solve, it's gonna be the exact same scenario, but one word is gonna be different. So to We're gonna isolate the variable. By doing the inverse of the coefficient. So notice, I'm not adding the opposite, I'm doing the inverse, so that's a different word. And I'm not doing the opposite of the constant, I'm doing the inverse of the coefficient. So let's bring that over here for just a second. So on our crossword, 6 across, a coefficient is a number that is multiplied by a variable. Okay, so notice a constant is over here, that one is being added or subtracted, a coefficient is being multiplied. So we're gonna be able to see what that looks like. And again, this is still review from 6th grade. So I'm gonna open up and I'm down at the bottom and I'm gonna start with this one, 5x equals 405. I'm gonna draw my line. We need to make sure that we remember, some of you guys might be able to figure out this in your head, right? Some of you might be able to figure that out in your head. However, we're learning the correct algebraic process. So when we have something that looks like this, right? When we have something that looks like this, there's no way we can do this in our head. So we need to know the algebraic process to get there. So we start small and then we build from there, okay? So we are showing all of our proficient work, so just make sure you're doing that. I'm gonna switch colors here. So this says, isolate the variable by doing the inverse of the coefficient. So this variable is being multiplied by 5. Here's your coefficient. 5 is your coefficient, right? So the inverse of multiplied by 5 is to divide by 5. So to get rid of multiply by 5, I'm gonna divide by 5. And we're gonna show that with a division, with a little division bar, like a fraction bar. We're not gonna write 5x divided by 5 anymore like this for equations, because this is really more of an elementary skill. This is what the algebraic step looks like, so that's why we're gonna do it that way, okay? Whatever you do to one side, you do to the other. 5 divided by 5 is 1, but we don't write 1x, okay? We just write x. I don't say, hey, can you get me a 1 glue stick? I just say, can you get me a glue stick? So that's why x is gonna be here. There is a 1 in front of it, but mathematically we don't write the 1, okay? 405 divided by 5, we would do some scratch work. That way we could get that answer. That answer actually is 81 if we were to do that scratch work, okay? Same thing, this check step would look a little bit different. So if I'm plugging in for my variable, there's not any addition, I would plug it in like this, which means 5 times 81 is 405. So what I should be able to do is 81 times 5, which is what this says. 5 times 1 is 5, 5 times 8 is 40, 405, and I got it right. The whole purpose of today is to use this vocabulary and to remind us of what is a constant and what is a coefficient. Okay, one more example for multiplication. So let's do negative 50 equals 2y. Again, I know that we could do this numerically in our head, but I want to show the actual algebraic process. So remember, a constant, if you're looking at your vocabulary crossword, is a number that's being multiplied by a variable. When they're right next to each other, that means multiplication. That is your coefficient, okay? So it says, isolate the variable by doing the inverse of the coefficient. Well, the inverse of times 2 is going to be to divide by 2. Whatever I do to one side, I do to the other. Here's where 2 divided by 2 equals 1, but again, we're not going to write 1y, we're just going to write y. 50 divided by 2 is 25, and a negative divided by a positive is a negative, okay? Let's do our check step for that one. Negative 50 equals 2 times negative 25. That one we can see pretty easily. 2 times 25 is 50, and a positive times a negative is a negative. So negative 50 equals negative 50, and we got it right. Okay? So the inverse of multiplication was division, right? So can you maybe make a guess about how we're going to do the inverse of division? You probably already know in your head. So to solve, it's going to be literally the exact same thing. We're going to isolate the variable by doing the inverse. But in this case, the inverse of division is multiplication of the coefficient. So same situation. Notice the rules for addition and subtraction both involve the constant, right? The rules for multiplication and division both involve the coefficient. So we're just gonna do 2 examples. So it's gonna look a little bit different. It's gonna look like x over 7 equals 13. The reason it looks like x over 7 is because this is the variable is being divided by 7, okay? So it says, isolate the variable by doing the inverse of the coefficient. So this is what is being multiplied by the variable. This actually, there's a 1 right here. So your coefficient is kind of 1 over 7, right? But we're gonna just view this as a division problem. So this means the variable is being divided by 7. And to get rid of the division, we want to do the inverse, which is multiplication. So the inverse of divide by 7 is gonna be to multiply by 7. Whatever we do to one side, we do to the other. Here, 7 divided by 7, just like over here, 2 divided by 2 would be 1y. 7 divided by 7 would be 1x. 13 times 7, we might do some scratch work somewhere on the side of our problem. 7 times 3 is 21. 7, 8, 9. We get 91. Still the same thing, we could do our check step here. The only difference is whenever I'm plugging in, 91 over 7 equals 13. So I wonder, 91 over 7 means I'm dividing, right? So I could do some checks and I could say, okay, 91 divided by 7. 7 goes into 9 one time. That's a 7. 7 goes into 21 3 times, and I get 13. So that is the correct answer. Okay, last example. Thank y'all for sticking with me. This is super important as far as vocabulary goes. Last example is gonna look like this. Negative 10 equals x over negative 5. Okay, negative 10 equals x over negative 5. So let's go back to our vocabulary. We're gonna isolate the variable by doing the inverse of the coefficient. So this one is the one that is with the variable. The variable is being divided by negative 5. So the inverse would be to multiply by negative 5. Notice, if it's divided by negative 5, I'm gonna multiply by negative 5. Adding and subtracting has to do with the opposite. This does not, this is inverse. Those are 2 separate words, right? So we have to be really careful. Whatever I do to one side, I do to the other. And I can just put them in parentheses to denote multiplication, right? These cancel, which is what we want. That means we have x over here, negative 5 times negative 10 is positive 50. And if we wanted to have proficient work, we're gonna do our check step, which means I'm gonna plug that 50 back in for x. 50 divided by negative 5, well, 50 divided by negative 5 is negative 10. So does negative 10 equal negative 10? Yes, it does. All right, so all of this is going to build into tomorrow, so make sure that you bring this back. These words, constant, coefficient, inverse, opposite, all of those are gonna come back in for the next few weeks, so make sure you're remembering those.